Hello friends, in this session we will discuss distresses in rigid payments. Rigid payments like flexible payments suffer from both major and minor distresses. And these distresses can broadly be divided into two categories. One is functional distresses, another is structural distresses. In this session we will discuss the functional distresses. There are several types of functional distresses, and these distresses do not necessarily reduce the load carrying capacity of the payments, but they do affect the riding quality and safety. These distresses can be summarized like this: mud pumping, roughness, loss of surface texture, faulting, scaling, raveling, pop out, surface delamination, map cracking, plastic shrinkage cracks, and polished aggregates. We shall discuss each of these in this session. Mud pumping. This is the process by which vertical movement of the base course pumps to the surface through the joints, cracks and edges of the rigid pavements and forms the soil slurry known as mud. So when heavy load passes over the pavement, the mud is ejected out through the joints and cracks of the pavement, and thus the mud pumping occurs. The reason for mud pumping is the moisture between subgrade and base course, or heavy loads, or lack of subgrade support, or combination of all these. But generally, when you have moisture in subgrade or in base course and heavy load passes over the pavement, then that is the reason for mud pumping. Remedial measures for mud pumping can be sealing with bitumen or cement, sealing of joints, sealing of cracks with bitumen and cement can be a very effective method to reduce the mud pumping. If mud pumping is very prominent, then in that case we repair this by cutting it the full depth of the slab and providing a patch. But when you provide a patch, then dowel bars can also be provided to increase the load transfer across any significant transverse joint created by this repair. Or it can be through mud jacking also. Now, mud jacking is the process of pumping cement slurry under the slab through a hole to lift the slab to its original position or original height. The second is roughness. Roughness is the term used for describing the unevenness or riding quality of the pavement as a whole. And it should be understood that roughness is different from texturing, which is used for skid resistance. And I will discuss this skid resistance or texturing in the next slide. Roughness can be because of curling or warping of the slab. Settlement and heaves can also result in local or overall road roughness. If the road roughness has occurred beyond the permissible limit, then slab jacking can be used to raise localized settlement in pavement. And slab jacking is the same as mud jacking. A series of small holes are drilled into the slab that needs repair or leveling, and then concrete lifting material like concrete mixture or any other material are injected into these holes. In the case of minor settlement and heaves, diamond grinding can be employed to reduce localized roughness. But when you use the combination of these two, slab jacking as well as diamond grinding, that can provide a relatively long-term solution to localized roughness. The third is loss of surface texture. Loss of surface texture is the measure of loss of skid resistance of concrete pavement surface. And with the time the texture abrades and skid resistance reduces, and that creates the problem of friction. This is measured by two methods, either by sand patch method or by British pendulum tester. The sand patch method is simple. It can be used in field. It is a volumetric approach to determine the average micro texture depth of the paved surface. Procedure is simple but very time consuming, and it cannot be done for the whole section. It can be done only on locations. British pendulum can also be used either in the field or in the laboratory. The loss of surface texture is mainly because of passage of heavy traffic or channelized traffic, but there can be several other reasons like movement of construction traffic at an early age, wear and tear under high volume of traffic, particularly under wet or uncleaned surface, poor texturing during construction itself, use of soft or monomineral aggregates, frequent braking and turning sections like intersections or speed breakers, or durability problem with the concrete. To improve the surface texture, either you provide a bonded concrete overlay or grinding can also produce surface texture in the longitudinal direction, and it can also help remove surface irregularities, means roughness also. The fourth is the faulting. Faulting is the relative movement of slab or difference in elevation at joints. So when one slab is depressed or settles down, then there will be difference in the elevation of two slabs or at joints, and that creates the problem of riding quality also. It can give a very rough riding if it is not maintained properly. It can result from a combination of factors, but main causes are settlement of the pavement that is caused due to soft foundation, the pumping or the erosion of material under the pavement resulting in voids under the pavement slab causing settlement. The temperature changes and moisture changes can result in the curling of the slab at edges, inefficient load transfer at joints, and therefore the load comes on the slab and that slab settles down. Curling, warping of the slab are also responsible for faulting. The remedial measures: faulting slab should be brought to the original level, so it can be lifted. Alternatively, high density polyurethane can be injected and it can be combined with concrete joint grinding, and that can be another method of repairing, and this is called poly grinding. The next is scaling in concrete pavements. Scaling is local flaking or peeling of finished surface of hardened concrete as a result of exposure to cycles of freezing and thawing. And therefore this distress is common when the pavement is laid in very cold climate. Generally it starts as localized small patches which later may merge and extend to expose large area. Light scaling does not expose the coarse aggregate, but when it becomes serious, coarse aggregates also get exposed. Scaling can be because of several reasons. Number one, the use of non-air entrained concrete or too little entrained air. Adequate air entrainment is necessary for protection against freezing and thawing damage. However, even air entrained concrete will scale if other precautions are not observed. Second, early age application of calcium or sodium chloride de-icing salts. If other salts such as ammonium sulfate or ammonium nitrate are used, they can cause scaling as well as severe chemical attack of the concrete surface. Any finishing operation performed while bleed water is on the surface. If bleed water is on the surface, then it can result in very high water cement ratio, and that will produce a surface layer which is weak. And the last is insufficient or no curing. This omission often results in a weak surface skin which will scale if it is exposed to freezing and thawing in the presence of moisture and de-icing salts. Once the scaling has occurred, the correction is that you remove all soft loose material, clean the surface of any dirt and debris, dampen the clean concrete area and apply a thin layer of cement paste, and then place proper concrete type to resurface the damaged area, or repair the affected area by slurry seal. Raveling, that is loss of fine aggregate from matrix and hardened cement paste from the surface through abrasion that may or may not have been previously cracked. So here cracking is not necessary. Raveling is basically loss of fine material from the surface of the pavement. It is primarily caused by poor binding of the cement with aggregate content of the concrete. But it is different from spalling. Spalling or scaling, they are typically caused by water infiltration into the concrete, which especially during freeze and thaw cycles can break up the concrete. Whereas raveling is the loss of fine material from the surface. Raveling is more an issue with pervious concrete, though it can also affect standard concrete, primarily at the joints. If joints are socket into the slab at wrong time, either too early or too late, raveling can occur along the edges. It is most often caused by rapid evaporation. If the concrete dries out too quickly, the bond of the cement will not be strong enough and rocks may come loose from the surface after curing. Thus, it is important to pay close attention to the weather when pouring pervious concrete, as excessive sun or wind can cause evaporation to happen too quickly. Next is pop out or mortar flaking. Pop outs are small fragments of pavement broken loose from the surface, normally ranging from 13 mm to 50 mm in diameter and in depth. They are generally caused by porous aggregates with high water absorption and relatively low specific gravity. A fractured aggregate particle or particle socket is typically found at the bottom of the depression where the pop out has occurred. Mortar flaking is the dislodging of small segments of mortar directly above coarse aggregate particles. Slight difference between the two. Concrete with a high volume of medium-sized aggregate pores like 0.1 to 0.5 micrometer that are easily saturated can absorb moisture and upon freezing can rupture the aggregate to create pop-outs. Also, aggregates that contain shale, soft and porous materials such as clay lumps or other deleterious materials and certain types of dirt may be prone to pop-outs. Prevention is to use durable concrete with low water cement ratio. Cover the surface after screeding. Cover the surface with plastic sheet to prevent evaporation prior to final finishing in hot, dry and windy conditions. Do not finish concrete that still has surface bleed water and begin curing as soon as possible. Use of wet curing methods or evaporation retarders to minimize moisture loss can also help reducing the pop out. Now, if the pop out has occurred, then the treatment is penetrating sealer. It can help waterproof the surface. If the wires are larger than 50 millimeter, which are generally caused by clay or soil balls, then they can be filled using approved repair materials. Or thin asphalt or concrete overlay may be appropriate when pop outs cover a significant portion of the slab within a project. Surface delamination or surface polishing. Delamination is the development of a horizontal crack within the slab that results in separation of the surface layer to a depth of 0.5 to 2 inch from the remaining concrete. Delamination may be limited or widespread depending upon the basic cause of the separation. It is generally seen adjacent to pavement edges and may extend 3 feet or more into the slab, but it can also occur anywhere in the slab. And there are several causes of delamination. Number one, a cool subgrade causes the underlying concrete to set more slowly. The concrete temperature or mixture ingredients impedes the concrete setting. Entrained air is present in the concrete or the overall air content is higher than wanted for the specific application. Higher cementitious material or sand fines content that can create a sticky concrete mixture. Environmental conditions can also result in surface delamination. Excessive vibration draws too much mortar to the surface. using a dry shake, especially with air entrained concrete, a thick concrete slab, or rusting of reinforcing steel in upper layer, which breaks the bonding between the steel and surrounding concrete. The repair of surface delamination or surface polishing. The first is patching. Patching is performed after removing the surface layer and thoroughly cleaning the underlying concrete. Grinding and laying a new surface may be necessary for extensive delamination, and when steel corrosion is visible, then sandblasting the steel is necessary for proper rust removal. Next is map cracking. Map cracking has a series of cracks that extend only into the upper surface of the slab. Larger cracks frequently are oriented in the longitudinal direction of the pavement, and they are interconnected by finer transverse or random cracks. This distress is the deterioration of the upper concrete slab surface, normally 3 mm to 12 mm, and it can occur anywhere over the pavement. Common causes of map cracking are coarse aggregate, expansion of the slab, chemically reactive aggregate, poor mix design, and improper curing. But overworking of the concrete surface or finishing while bleed water is present on the surface can cause significant weakening of the surface layer, and that can also contribute to the formation of map cracking. Map cracking can be prevented by several measures. Refrain from spraying water on surface during finishing. Spraying water on the surface during finishing raises the water cement ratio of the surface and creates a weak layer of mortar that shrinks and leads to the formation of map cracking. Number 2, avoid sprinkling cement on the surface to dry bleed water. Cement that is sprinkled on the surface in an attempt to absorb bleed water will dry rapidly and shrink, leading to additional map cracking. And the third is avoid finishing while bleed water is present. Finishing while bleed water is present on the surface can cause significant weakening of the material at the surface, and that can contribute to the formation of map cracking and other surface defects. Diamond grinding can be used to remove surface cracking. That is the only treatment which is possible for map cracking. Next is plastic shrinkage cracks. Plastic shrinkage cracking is caused by the rapid loss of water from the surface of the fresh concrete. The cracks form when the rate of evaporation is greater than the concrete's bleeding rate, and these are generally parallel to the moving traffic. Shrinkage cracking is an early age pavement distress that forms before the setting of the concrete. These cracks can occur when construction takes place in hot weather. The climatic conditions that are suitable for their formation are high concrete temperature, low ambient relative humidity, or high wind velocity. There are mixture properties also that can encourage the shrinkage cracks, like type and content of the cement and supplementary cementitious materials, water cementitious material ratio, and type and dose of chemical admixtures and temperature of the fresh concrete. Even construction operations, including screeding and finishing operations, can influence the risk of plastic shrinkage crackings. The plastic shrinkage may be repaired in plastic state by reworking the concrete surface using surface vibrators to close the cracks over their full depth and then completed by surface finishing. If the concrete has hardened, then you have to see whether these cracks are dormant or active. Dormant cracks are stable and future movement are not anticipated, or in other words, unlikely to open, close, or extend further. Fine hairline cracks generally do not need any repair, but these cracks may prove to be a future durability problem and therefore it is always recommended to seal them either using a bonded overlay or some type of surface treatment. Wide cracks may be sealed by epoxy, polyurethane, or acrylic resins followed by a protective coating membrane. When the cracks are active, now active crack basically means that they will experience further movement and growth. That cracks may be resulting from continuous foundation settlement, or the cracks are acting as contraction and expansion joints. These cracks should be treated as if they are moving joints, and the repair should cater for the anticipated potential movement. V-cutting along the line of the crack and then sealing it with appropriate sealant material will protect against further expansion of the crack and possible water ingress. Then polished aggregates. Aggregate polishing is caused by repeated traffic applications. Their surface becomes very smooth. It is recognized by the surface that has become flat and polished following the wearing away of the mortar over coarse monomineral or soft aggregates. As a pavement ages, the protruding rough angular particles become polished, and this can occur quickly if the aggregate is susceptible to abrasion. Diamond grinding is the only option for repair of polished aggregates. So friends, thank you very much for watching this video. You can write your suggestions in the comment box.